Good morning students. JNTUK Kakinada R23 regulation unit number 3 engineering physics unit number 3 dielectric properties. Dantlo in this I am going to explain the types of polarizations. The first one is electronic polarization. The second one is ionic polarization. The third one is dipolar polarization or orientation polarization. The fourth one is space charge polarization. In this, let me explain about the electronic polarization. We know in the absence of electric field, the structure of the atom, suppose here it is the center of the atom, that is called as a nucleus. The charge of the nucleus is plus Ze. Around the nucleus there is a electron cloud. The charge of the electron cloud is minus Ze. Suppose if at all we apply some electric field E on the atom, what happens? There is some electric strain will be produced. That means by means of the electric strain, there is some deformation of the atom will be takes place. The deformation is because of the Lorentz force which will come into existence because of the applied electric field. So because of the Lorentz force, the atom is going to be deformed, and we can write down the expression for the Lorentz force. The Lorentz force is Fl is equal to Ze into E. That means the charge of the electron cloud minus Ze into applied electric field intensity E. So the Lorentz force Fl is equal to minus Ze into E. Because of the applied electric field intensity E, there is some deformation, and after some time the atom tends to regain its original position because of the Coulombic force. The Coulombic force will be Fc is equal to charge into, we know the Coulombic force, 1 by 4 pi epsilon naught into charge in the sphere of radius d divided by d square. See, here there is a sphere of radius d that is formed because of the that is the center of the electron cloud. The center of the electron cloud is located at d units from the center of the atom. So the center of the electron cloud is located at a distance of d from the center of the atom. So there is a sphere which is formed with a radius of d. So Coulombic force Fc is equal to Ze into 1 by 4 pi epsilon naught into change in the charge in the sphere of radius d divided by d square. Now we need to calculate the charge at inside of the sphere d. The charge at inside of the sphere d is equals to, we know the density d is equal to charge per unit volume. From this, charge is equal to density into volume, and volume of the sphere of radius d is 4/3 pi d cube into the charge d. So charge is equal to volume into density, volume term 4/3 pi r cube, that means 4/3 pi d cube into density term rho. So that is equals to 4/3 pi d cube into rho. Rho means here the term rho means the negative charge density of the sphere of radius r. How can we get the negative charge density of the sphere of radius r? So density rho is equal to charge per unit volume, and charge is equal to minus Ze divided by 4/3 pi r cube. From this, rho is equal to minus 3 by 4 into Ze by pi r cube, and the same term will be incorporated here. Substitute here, then we get 4/3 pi d cube into rho. Rho means 3 by 4 minus 3 by 4 Ze divided by pi r cube. By calculation, by simplification, we get the value of minus Ze d cube by r cube. This is the charge at inside of the sphere d. So substitute this value minus Ze d cube by r cube value here at charge at inside of the sphere d. Then Coulombic force can be obtained as Fc is equals to Ze into 1 by 4 pi epsilon naught into charge at inside of the sphere. What is the value? Minus Z d into d cube by r cube. Minus Z d into d cube by r cube divided by d square. The same value we substituted here. So by calculation we get Fc is equal to minus Z d into Z d square d cube d divided by 4 pi epsilon naught r cube. Simply. This is the Coulombic force. So the Coulombic force is Fc is equal to minus Z square d by 4 pi epsilon naught r cube. See, after we are applying some electric field intensity E, actually there is some deformation, and later on the equilibrium position may change, but anyhow there is some equilibrium position is coming to existence. After equilibrium, the Lorentz force is equals to Coulombic force. Fl is equals to Fc. So equating these two values, Lorentz force, we know the Lorentz force is equals to minus Zd into E, minus Zd into E is equals to Coulombic force minus Zd square d by 4 pi epsilon naught r cube. Zd square cancelled out. So finally E is equal to Zd into d by 4 pi epsilon naught r cube. But we know that the dipole moment is mu E is equals to Zd into d. That means charge into distance or charge into displacement. Here in this case, charge into displacement. So the dipole moment mu E is equal to charge into displacement. So already we have the term charge into displacement. So E into 4 pi epsilon naught r cube is equals to mu E. Simply mu E is equal to E into 4 pi epsilon naught into r cube. Now electronic polarization can be obtained from Pe is equal to 1 by V into mu E. That means mu E by V. So Pe is equal to mu E by V. That means 1 by V can be written as N, capital N. So N is the N into 4 pi epsilon naught r cube into E. And electronic polarizability is alpha E is equal to electronic polarization per applied electric field intensity E. So Pe by E. Already we get the value of Pe. N into 4 pi epsilon naught r cube into E divided by E. Totally we get the value of electronic polarizability. Alpha E is equal to N into 4 pi epsilon naught into r cube. So in order to get the electronic polarizability, we need to find out electronic polarization. In order to get the electronic polarization, we need to get the dipole moment. In order to get the dipole moment, we need to calculate the displacement. So from the displacement term, we get the value of dipole moment. From displacement to dipole moment, from dipole moment to polarization, and from polarization, polarizability. This is the sequence we need to calculate, get calculation. So first of all we get displacement, from that we calculated dipole moment, from that polarization, from that polarizability. Thank you.